Hey everybody, this is Larry. This is me trying to do a quick random algo prompt I haven't done yet. Let's go. I don't know why I'm tired today. I say that every day anyway, so whether I'm tired or not, who knows. But today we're gonna get 666. What? This is so intense. How have I not done this bit? Anyway, okay, whatever. Path sum 4. Yeah, hopefully this is not a sign of anything devious, if you will. But okay, if the depth of a tree is smaller than 5, then this tree can represent an array of 3-digit numbers. For each integer in this array, the 100-digit represents the depth. Oh. I feel like this reminds me of a problem that Josh asked that I had no idea what he was talking about during one of the contests. But if I had saw this, maybe I would have some idea incepted into my head. I don't know. But yeah, okay. Yeah, I mean, yeah. This is actually a cute one. Alright, the sum of all paths from the root toward the leaves. Okay, so nums is 113. What? Okay. So that means that the first. I'm trying to see. This is a little bit tricky to understand. The depth. So the depth is 1. The position of the node of the level is going to be also 1, and this is a 3. Okay. Oh, so it's 1 base. Whoops, that's what I was getting confused about. And then 215, 221. Okay. So it has at most 15 numbers. And a depth less than 5. Okay. The position is so weird, right? Because position is not always the parent. Oh, the full binary tree. Okay, so okay. I guess that makes sense. I'm trying to think whether there's like a clever way of doing it. I mean, of course we can reconstruct a tree or whatever, and then that's fine too. But yeah, I mean, are these in order? No, I think we can sort them anyway. Yeah, so because the first two, the hundreds and the 10th digits will unique. They're just unique, right? So you uniquely determine the thing, and then the sum is just gonna be the thing, right? So the sum of all paths from the root to the leaves, right? This is like such a weird problem. I mean, you can just construct a tree, I guess, if there's only 15 nodes. I'm just trying to be lazy. Well, like I'm trying to find something cleverer, but maybe I don't. Right? I mean, we can just also represent this tree as a nums array. And 5 depth was that 2 to the 5th is 32 or something, right? And it only goes to 2 to the 4, so it is even less. So we definitely can do that, but yeah, maybe I'll just write that way and then we'll see. Is it 15 or 16? I don't know. Right, and then now for x in nums, right, we can say the depth and the position. How do I convert that into a number in the old style thing, right? So the depth so okay, so I see, okay. So for each depth, okay, oh yeah, d is equal to x over 100. What's it? 10 is p. Okay, fine. Is equal to p divided by 10 mod 10, and then v is equal to x mod 10. Okay. And then now, so for every d, we go up 2, right? So it'll go from 0. Well, it'll be 2 to the d minus 1 plus p is what we want, right? So yeah, 2 to the d minus 1 plus p. This is the position in tree, and is equal to v, right? Let's print it out real quick. I think we're off by 1 somewhere because this depth thing is a little bit awkward. Well, not awkward. It's just that I think this, yeah, maybe this is a little bit better. And p as well because it's 1 to 8. So okay, fine. Let's run it real quick. So here we have 3, 5, 1, which is what we expect. Let's also run the other one real quick. Should be 3, none, 1. Yeah. So here maybe we're okay. I don't know we're okay for whatever, but let's just add one with 4, 8, 9 just for fun, just to make sure that we didn't go out of bounds. I think that's the whoops. Yeah, I guess that makes sense. Because we need a 3 depth thing, right? So 3, 4, 2 maybe. Okay, so it doesn't go out of bounds. The 9 is all the way up here, so that's good. Because I think that's as far as it goes. I thought it was 15 too, but I put 16 for some reason because it doesn't even make sense. But okay, fine. It shouldn't matter. All right, so then now, now the way to do some of the paths is, yeah, just recursion up, right? Or like DP backup, if you want to call it that, because then now we can do something like I and length of tree minus 1, and then we just go over it that way. And the way that this goes is just that I over 2 is the parent. So we can just roll it up, but then now the parent also counts, like maybe like a children thing, even though that's now, it makes it a little bit awkward, right? And then now what that does is that I guess that's it really. And then now if tree of I times 2 plus 1, I don't know, the way that I write this is so awkward. That's why I'm like struggling. I'm not even struggling. If this was a contest, I could have got it done very quickly, but I just hate the way that I did this, to be honest. Yeah. Because basically now you multiply it by the number of children that it has. Right? Because if it has 2 children, then and you kind of DP up to go that way, and then just kind of do it that way. But yeah, okay. If there's no children, then it is the child. That's the part that's always a little bit tricky as well. Yeah, okay, fine. If children sub I is equal to 2, then tree sub I, we times it by 2 because you want to double count it. And then otherwise you just kind of I don't know that I recommend doing it this way. I feel very dumb. I think like I did a lot of work to not do a lot of work, which is creating the tree, which we probably could have, and then just do a depth first search, and you know, that's just 15 nodes. It is like pretty silly the way that I'm doing it. I think it might not even be right. Oh yeah, I that's the other thing that part I knew I needed to check, but I forgot. Yeah, maybe I should have just done the depth first search way with a node, but wait, where? Oh, forgot about it. All right, I mean, yeah, let's give it a submit. Hopefully, I didn't make. Oh, how did I miss a wrong answer? So this is 6 and why did I get 9? Hmm. Why do I get 9? See, this is also what happens when you try to be too clever, is that now you have to debug the cleverness. Where if we just do a depth first search, I'm like 100, or like 99 out of 100 times it's gonna be right because done depth first search. And if I make a mistake, it's such an obvious thing to debug. Why do you have 2 Chaya? Tell me why. Oh, because I is 0. But did I needed that by accident somehow? Okay, so 3. Yeah, I mean, so this is 6 plus 5 plus 1, right? So 3 plus 5 plus 1. Did this not happen? Hmm. You have 3, 0, 1, 2, 2. Oh, I forgot that I'm doing. Okay, that's not the actual parent, is it? Yeah, okay. I forgot that I'm using the other version of. I don't like this version though. I like the one index version. This is one of the rare cases. This is also what happens when you do silly things. You do silly things, you get silly results. I mean, I don't even need to do this in a really silly DP kind of way. I mean, I thought it would be cool. I actually don't. I don't even know if I want to debug this. I just don't care about it too much. I'm just being very sloppy. What am I doing? All right, pretend this is a contest. Let's do it, Larry. All right, let's just do a depth first search and don't do it dumbly. Yeah. Okay. So then you have the node, right? So yeah, if tree of node is none, we return 0, right? So then now the depth first search is just that, and you could do it in 2 ways. You could actually return the answer and it'll be similar to what we did, but I'm just very tired right now, so I'm just going to be doing this. And then yeah, if tree is none, okay. So then now if I guess it's just return. We don't actually return anything anymore. Okay, so then now, if this is a leaf, which is if node times 2 plus 1 is none, and time 2 is none, and node plus 2 is less than length of tree. We probably could have just used an actual tree at this point instead of all these. So this is a right. Yeah. I think current we want to add it to tree of node, and then else, if this is not, then we go DFS node. Yeah, times 2 plus 1 current. And that's pretty much it. DFS 0 index 0 things. We return answer. We have to do another gating of if node is greater than length of tree, then we just return because that means that we fell off the tree. How do we get wrong answer here? 15 and what's it? This so I don't know why you can like this is so hard to look at. I mean 0 is clearly wrong. If this is a leaf, otherwise we do add the tree node. Huh, why am I wrong here? Wow, I'm just like really bad today. I can, this thing is like very hard to see, so I'm just gonna move it up. I don't know why I'm returning 0. None of this should be 0, right? No matter what. Yeah, so then that means that this is, oh, because of this less than statement. That's why. Wow. So, I see. I'm just being way, so okay. I mean, I think this is true, but it's still very awkward. Everything is always awkward. I should have just created an actual real tree. Do I print stuff? No? Okay, let's give it a submit. Yeah, I don't know. I try to be too clever on this one. I think the unique data representation of this tree kind of made me want to do something unique, but I think I was just being too clever. I think what I would have done instead is just put it in a, put in an actual tree node thing and put in a class and do it right. This is gonna be it's gonna be linear time, linear space, linear space to do this, and this for stack. You may say that the depth first search is actually much slower than the other one, the for loop that I had, which is true, but each node is on average gonna, because basically you have this on the leaf level, you're gonna look at each of these ones, and then on the higher level, you're gonna look at each of them at most twice, but it's gonna be n over 2, right? So then on the third level, it's gonna, oh, that's n log n then, isn't it? Maybe it's n log n. I don't know. Well, we don't. No. That's not true. It's just a regular depth first search. It's linear, right? I'm counting the number of summing. I'm just being dumb today. But no. Yeah, we look at each node only once. So this is linear time, linear space. That's all I have for this one. Let me know what you think. Thanks for watching. Maybe this problem, you can say this problem bedeviled me. It's really not so bad though. It got a lot of downvotes, but I don't think it's that bad. It's just that I think I try to be too clever for this one as well. So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. Have a great weekend, everybody. I'll see y'all later and take care. Bye bye.